Hello my dear children of class 11 science. Today we will start new chapter, a very short chapter under unit number 8. See, we are still in unit number 8 and the chapter that we are going to start today is isothermal and adiabatic processes. Now you have learned in brief about these two processes in the previous chapter in thermodynamics. Okay, but in this chapter we learn in detail about the isothermal process as well as the adiabatic processes. So as you know that thermodynamic processes are different types. There are many thermodynamic processes that you have learned. Like you learn about what isobaric process, you learn about isobaric process, you learn about isolated system. Okay, means there are a number of processes or system under thermodynamics that can happen. Okay, and this process can observe day-to-day life. But out of many processes, the two processes which are important and you have to learn in detail, okay, and that is isothermal and adiabatic processes. Okay, so first of all we start with one of the process called isothermal process. Okay, so let's go start with what? Isothermal process. Now let me just write it out, the heading, isothermal process. Now you have some idea about isothermal process. Now to start with this topic, iso means same and this thermal is related to temperature. Thermal related to what? Temperature. Now from here only I can say that isothermal process is that process, okay, thermodynamic process in which the temperature remain what? Same, or temperature remain what? Constant. That means in this process what happened? The temperature remain constant. So just writing the point, temperature remain what? Remains constant. Now temperature remain constant. It's like I don't T equals to is the temperature and this remain constant. Now when temperature remain constant means the change in temperature becomes 0. The change in temperature becomes 0. And such process, thermodynamic process, is simply known as isothermal process. So children, we can even define the isothermal process as a process in which when a system undergoes, system is thermodynamic system, okay, undergoes a physical change, a change in the what? Size, shape, dimension, okay, change in the density or volume, okay, under the condition that the temperature of the system remain what? Constant. Means systems have a physical change but without changing the temperature, and such process is called isothermal process. So remember this part, that in case of isothermal process the system undergoes a what change? Physical change, okay, undergoes a physical change but without changing the temperature of the system, and such process is defined as isothermal process. So when you write the statement of isothermal process, we can write the statement this way. Okay, now for this process to take place, now it doesn't mean that all the system undergoes isothermal process once the system has a physical change. It does not necessary. So there are certain important conditions that we need to understand and need to follow for changing the what? Undergoes a what? Isothermal process. So that's why for a isothermal process to take place, it is very necessary that the system must be surrounded by a perfectly conducting material. Conducting what? Material. So let me just add next point for isothermal process. Okay, for isothermal process, okay, the system, okay, must be what? System must be surrounded by, okay, let me just write it down. System must be surrounded by a perfectly conducting material. Perfectly conducting what? Material. So this is one of the important conditions for isothermal process to take place. Now why it is so important? Because the heat that is produced in the process, the heat produced in the what? Process, okay, is immediately goes out from the system to the what? Surrounding. Because under thermodynamic process there must be system and the surrounding. Like I'll give you the example, like gas. Gas can be a system. It can be enclosed in a vessel. Now vessel act as a what? Surrounding. Okay. So when an isothermal process takes place, remember this part, that the temperature remains constant, so that the heat producing in the process, should go immediately from the what? System to the what? Surrounding. Or even suppose the heat is absorbed, okay, come from the surrounding into the system, okay, that has to be absorbed immediately. That has to be absorbed what? Immediately. That means any heat absorbed come from the surrounding into the system has to be absorbed immediately. So that can be done only by keeping a system in the what material? Perfectly conducting material. Because perfectly conducting material simply can quickly transfer the heat between the system and the surrounding. Either heat can be absorbed by the system or heat can be released by the system to the surrounding. But it has to be occurs very fast, so that the temperature of the system must remain what? Same. That's why one of the most important case is that in isothermal process the temperature remains constant. If the temperature does not remain constant, that process cannot be called as isothermal process. Okay, so for this process to occur, as I said, the system must be surrounded by perfectly conducting material. But children, in actual practice, there is no material which is perfectly conducting. Now, this perfectly conducting material is impossible to obtain in actual practice. Okay, that's why the perfect isothermal process, perfect isothermal process is actually impossible. Okay, perfectly what? Impossible. So this is only an imaginary thought. So perfect isothermal process, let me just write down, perfect isothermal process is simply an what thought? Imaginary thought. We just consider only imaginary thought. Okay, because there is no material which is perfectly conducting. Okay, perfectly what? Conducting. So this is the case under theoretical consideration. Now, but this isothermal process can be considered can be observed approximately. Can be observed what? Approximately. Okay. So for that, when the process takes place very slowly, now this part you need to understand, when the process takes place very slowly, so that the heat finds sufficient time to flow. Heat can find sufficient time to flow, then the process is almost approximately considered as what? Isothermal process. So approximate isothermal process can take place when the process takes place very, very slowly. Okay, so this type of process can be observed with the gas, and this gas is not a real gas. Okay, and this gas is also considered as what gas? Ideal gas. So ideal gas, now there is a term I am using out here again, ideal gas. Ideal gas is also called perfect gas. Perfect what? Gas. Now you have learned about the gas, but you don't know about what is ideal gas or real gas and all. Okay, now children, the detailed part of this gas you learn in the next unit, kinetic theory of gas. But let me just tell you that ideal gas or perfect gas means those gases, okay, which is also considered as an imaginary gas. Okay, it's not a real gas, but these are the gases which exactly follow the law like Bose Law, Charles Law. I know you have learned these laws in class 9 also. Okay, you'll be learning in the next unit also, Bose Law, Charles Law, okay, and gas equation and gas law. It also follow what law? Gas law. And these are the gases, okay, whose force of interaction between the molecules is almost negligible. There is no force of interaction between the molecules. The molecules are very, very small in size, infinitely small molecules. Okay, and those molecules of the gas, which are very, very small in size, they are very, very far away from each other, so that there is no force of attraction between the molecules. Okay, and those gases which exactly follow Bose law, Charles law, and gas law, and cannot be converted into liquid. Remember this part, children, also cannot be converted into liquid are called ideal gas. Also called what gas? Ideal gas. It can be any gas like oxygen gas, it can be hydrogen gas, it can be nitrogen gas and all. But this consideration of the gas is called ideal gas. So this is also an imaginary gas. Okay, so suppose I consider this as ideal gas. So this ideal gas I consider as a system. This is a what? System. Now this gas is enclosed in a vessel. made up of what? Conductor. But what type of conductor? Say a perfect conductor. Okay, like a perfect conductor. Okay, then this gas, when this gas is compressed slowly, or this gas can be expanded very slowly, okay, so that we give what sufficient time to give sufficient time to take the heat to flow, okay, between the system and the surrounding, so that without changing the temperature, then such process can also be considered as what process? Isothermal process. Can also be considered what process? Isothermal process. So for isothermal process, okay, the temperature must remain what? Constant. That's why children, in case of isothermal process, if I take gas as an ideal gas, okay, and it is enclosed in a vessel, okay, with the help of piston, okay, then if this gas exactly follow a law, so I'll tell you one of the law which follow by this gas known as Bose Law. And children, you have learned in class 9, Bose Law. Now Bose Law is that law, okay, which exactly applied for the what? Ideal gas, okay, when the temperature of the gas remain what? Constant. So when the temperature of gas remain constant, the pressure and the volume are inversely proportional to each other. When volume increases, pressure what? Decreases, but without changing the temperature, okay. And that can be observed with this diagram also, because when this gas is enclosed in a vessel, has acquired certain volume, but when this gas is compressed very slowly, just listen carefully, when this gas is compressed very slowly by the movement of piston very slowly, then what happens? The pressure increases, the volume decreases, but without changing the what? Temperature. And such process can be observed as what process? Isothermal process. That's why ideal gas exactly follow Bose Law, because Bose Law means temperature remain what? Constant. But this is true only when we take the system as a what gas? Ideal gas. That's why children, as I said, that ideal gas as a system follow what law? Bose Law. And you know, when we state Bose Law, we can write the Bose Law as, when temperature remain constant, as you know, pressure, P is pressure and B is volume, are inversely proportional to each other. Okay, so P is inversely proportional to B. That means inversely proportional to B. So it means I can write then P equals to constant by B, which means the product PB is constant. PB is what? Constant. So product of pressure and volume is always constant, and this is the statement of what? Bose Law. Which means if PB is constant, means you can even write this as P1 B1 equals to P2 B2. Yes, P1 B1 equals to P2 B2. That means the product of P1 B1 is always equals to product of P2 and what? B2. So this is Bose Law. So then this is what? Bose Law. So isothermal process follow which law? Bose Law. But even you know, children, that when we take ideal gas, or we can simply take a gas, then the temperature is actually depends on the factor called internal energy. Or I can simply say that internal energy, okay, of a gas, of what gas, depends only upon the what temperature. So if gas is as a system, if I take system as a gas, okay, then the internal energy of the gas is depend only on the what? Temperature. So what do you mean by this statement? So in isothermal process, temperature remain constant, so internal energy also remain constant. So in isothermal process, internal energy also remain constant. Also remains what? Constant. So remember this. What are the factors that remain constant in ideal gas on the isothermal process? Temperature, as it must remain constant, so that due to temperature which remain constant, the internal energy must also remain constant. Okay, that means there is no change in the internal energy of the ideal gas. That's why children, you should remember for isothermal process is that it is a physical process but a slow process. So isothermal process is not a fast process, it is a slow process. Okay, and in this process what will change? Pressure and volume will change. Pressure and what? Volume changes without changing what? Temperature. Without changing temperature. So if the process takes place by the change in pressure and volume, but without change in temperature means what process? Isothermal process. Okay. Now in this process, when we take the system, this system has to be enclosed in a vessel, or like say in a cylinder, or in a cylinder or cylindrical vessel. Must be what? A conducting vessel. Must be a perfectly conducting material. Okay. That's why there must be an exchange of heat between the system and surrounding. So in case of isothermal process, remember this, there must be the exchange of heat between the system and surrounding. And for exchange of heat between system and surrounding, the system must be bounded by the perfectly conducting material. Okay. So children, I have explained in detail about the isothermal process. Okay. Now in the next YouTube video, you learn about the isothermal curve. Okay, you learn about the isothermal curve, and most important part, we learn after that the adiabatic process, another process called adiabatic process. Thank you so much.